Hello, happy Friday, everybody. Today, okay, so I wasn't here last week because I was visiting my family, and the week before that, we got started on the deep learning project, and we're not gonna do the deep learning project today because I'm getting sidetracked, which is, that's probably my fatal flaw, is that I get sidetracked too much. So today we're going to be looking at this right here. So this is a figure. Let me zoom in a little bit so it's a little bit easier for y'all to see. So this is a figure from a Kaggle kernel that I tweeted about. And it's the percentage of developers, well, people who did the Stack Overflow Developer survey, who would do an unethical project. And you'll notice that the bar that is smallest is social science. And I said something kind of snarky about, like, we need people with social science backgrounds in tech, which I also believe. And a lot of people were like, Rachel, is this robust? Like, is this a real effect? And I got to thinking about it, and I was like, you know what? Excellent question. Let's find out. So today, what we're going to do is we're going to find out how robust this effect is, also control for some other factors like age or whether you put code into production or not, and yeah, find out what the answer is. So this is based on somebody else's kernel that I already loaded ahead of time, and I'm just loading again for fun, I guess. Oh, nope. Okay, good. I didn't actually click. So let's fork this script and get to taking a look at it. Oh, it's R Markdown. I don't think I've done R Markdown anything in this. Yes, I know. Thank you. I don't think I've done an R Markdown anything in this series before. I'm gonna zoom in a little bit. Y'all have to tell me if this is good for you in terms of being able to read things. If I zoom in that far, I get like a weird blank bar at the bottom. So this is where I'm gonna be, and hopefully this is good to look at with your eyes, and let me know if it's not. Yeah, I'm gonna get rid of a bunch of this, so I don't need a lot of that. I am gonna want this cell where we load in all the packages and data. I'm gonna get rid of this cell where we so get rid of this text here. Let's look at the console. Let's make that a little bit bigger. And let's actually run some of this so we can work with it locally. So something was masked, that's fine. So if you haven't worked with a script before, it's not like a notebook where you can just like run your cell and then look at the output. You run it from top to bottom, or you can run it in the console. So it's more like, just like a script of whatever flavor you are used to working with. So like a .py file or whatever. Okay, and I am just gonna take a look at this data ethics. I'm typing down here in the bottom. Ethics choice. And let's just take a look at the head of that and print that out and see what that looks like. Assuming I spelled it correctly. Oop. Yep, that correct. Okay, so there are some answers. People could say no, depends on what it is. NA, no, depends on what it is. One thing I am interested in is what the exact wording of this question was. So if we look at this, it's the percentage who would do an unethical project. So it's just the people who said yes to the question. And the question was, let's see, survey results. Here we go. So we can get the question tests. And I think it was like ethics choice. Scroll. Sorry, it's a little bit funky on account of the scrolling weird. Whoop. So I'm just gonna search for ethics, and then I'll zoom in so y'all can see it a little bit easier. Oh, okay. When I scrolled out, it popped me out of the preview. I don't want the results. I want the schema, and I want to know about ethics. So the exact wording of the question, I think this is important, was show me my results. I think it looks like some stuff at the bottom is cut off here. Here we go. Imagine, so the question that people are answering yes to, ethics choice. Thank you. Medig. Imagine that you were asked to write code for a purpose or product you consider extremely unethical. Do you write the code anyway? So that's the question we're answering here. And I'm going to copy and paste this into our thingadoogle. Yeah, I can't see it if I'm zoomed out a little bit. And so this is sort of like the baseline. And then there's another one. Do you report or otherwise call out the unethical code in question? And then who do you believe is responsible for having written this code? Who do you believe is ultimately most responsible for code that accomplishes something unethical? And I think we might end up looking at all three of those. I think that would be good. No, I can't do it. Sorry, y'all. I cannot work in a, no, I don't want a new window. I just want a new tab. There we go. Doing this sort of like exploratory data analysis, not in a notebook. It just drives me nuts at this point. So I'm actually going to do a new kernel that is a notebook. Because when you fork a kernel, you get whatever the original version was. Ethics choice, exploration. I do not want Python. Thank you very much. And then I'm just going to copy and paste the code for loading in the data and pre-processing, which seems to be fairly minimal. Fixed level of undergraduate majors. Oh, actually, you know what? No, it is actually not that minimal. So it looks like there's quite a bit of tidying of the majors, which is one of the things we're going to be looking at. So, no, I still don't want it to be in Python. Well, that doesn't look good. I'm getting an unknown backend error occurred. And I was actually getting a similar error earlier, and I thought it was just because I was working on a specific data set. But I guess it is possible. All right, let's back out and then come back in. I guess it's possible you can't change from a Python to an R kernel right now? That would stink. I may have to file a quick bug report if I can't get this to work. It may be because I've added a cell. I don't know why that would do it though. All right, can you give me R? Fascinating. Okay, it's loading. It didn't change the boilerplate text. I still have the default Python boilerplate text. All right, draft saved. Oh, I actually want this to be in a text cell. And exploration, let's give it a helpful title. Exploration. And let's just grab all this code. And I'm going to and there's going to be some wrapping around. Yeah, that we can get rid of. And we don't care about chunk options because that is a R markdown thing. So let's run all of this and see if it runs. A little star means it's running. Let me zoom in a little bit. So let's talk about in this code cell, we're waiting for all this pre-processing to happen. Let's talk a little bit about what we are interested in doing. In this notebook, we'll explore what factors are related to a developer answer to these questions. All right, so we've done all our pre-processing. Something's been masked from dplyr, that's fine. Oh, we actually probably don't need knitter. I'll just leave it in. He might end up using it for something something exciting. All right, I don't need the console because I'm not going to be using this because it's proportion of users in each age category. I don't care about that. Age and feeling like a part of the community. Not interested in that. Nope. Nope. Tools, gender, orientation, sexuality. Nope, 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 nope. Community membership. Proportion of users in each category. No. Gender, sexuality, major. Proportion feeling part of the community. Nope. So here we have the sort of summary. There we go. So here we have the summary of how people are answering this question. Most people are saying no, and the ethics choice question is this one. Scroll. Oh, no, that's not what I want. Let's make this into a bulleted list so that I can keep my line order. The question is this one. Imagine you were asked to write code for a project, purpose or product you consider extremely unethical. Do you write the code anyway? And still like 3,000 people said yes. Medig asks, undergrad major? Yeah, that is the thing that they majored in undergrad, which is this one. And we'll get to there. Okay, so here we are looking at age versus what they would do ethically. Let's copy and paste this. And don't worry, I will. Actually, let me do it right now while I'm thinking about it. Copy link address. Crediting the author of most of this code. This analysis is based on this notebook by what's his username? Hisu37. Oh, we have @ now. We've added that, so you get a little notification if somebody @ you. That is fairly new, and I'm very excited about it. Okay, so this should be ethics choice by age. Scroll a little bit so we can see these plots. Excellent. That looks like it is the same as it is in the original script. Gender. So we're going to look at sort of like all these plots, and then we're going to do some statistical analysis to see if these differences are very robust. So the gender, I think that looks the same as well. And sexual orientation, I guess we can do this one. I feel like we're getting a little bit in the weeds because the one that I was most interested in was undergraduate major. Yes. All right. And this is the last thing that the author, nope, go away. The last chart that the author did. So the original author, Hisu, was looking at age, gender, sexuality, or sexual orientation, and undergraduate major. And what we are going to do is we're going to look at which of these are if any, strong predictors. So for this, because it is a yes, no, depends. So there's a binary choice here as well. And I think that this might be the simplest way to look at this because we already have a lot of factors with a lot of levels. So I'm going to model the binary, whether or not you would do something choice given all of these factors. So the first thing I'm going to do is I'm trying to decide if I want to do a mixed effects model or just like basic regression. And I think I just want to do basic regression because there's nothing I want to control for here, right? I want to know if all of these things have an effect. And I don't want to say if we hold age constant. Well, no, I do, but I want to look at all of the interactions. So I think just straight up logistic regression is going to be our best choice here. I don't think I actually need to load in a library for that. So, because I believe logistic regression is built into the linear modeling LM. Oh my god, what's it called? Function. The function that is built into our wowzers. Yes, can be used out to carry out regression, blah, blah, blah. Do I need to specify anything in particular for a binary choice? Excuse me. Models are specified symbolically, response plus terms, first plus second, which is what we're going to be doing. So I'm just skimming now, and then I'll talk through what I'm doing as I get further into it. And these are the outputs. And okay, so I think we can just do LM. What was this data frame even called? Just data? Data, yeah. Data. You know what? A lot of times when I'm working, what I will do is I will look at just the head of the data frame I'm looking at, so I can see the column names, but we have too many of those, so I'm actually going to print out the names of the data frame, so I have just a list of them to look at, so I can make sure I type them good. All right, so let's do ethics choice by. So that's going to be our output, whether or not someone says yes when you ask them if they would do an unethical thing. And we were interested in, and I don't have to specify data every time. So this is the data frame, $, just says within that data frame, I want a column, and then the column is ethics choice by in this case. So this is what I'm predicting, my output variable, and my input variables are going to be age, gender, sexuality, and undergraduate major. So gender plus, and I don't have a reason to believe that these are going to interact. I believe it's just sexuality. Yes. I'm also interested in undergraduate major, and I'm also interested in age. What was that? What was age called? Okay, just age. Just age is what it was called. All right. Okay, So we have the coefficients. Oh, right, we're gonna need the summary. So let's save this. Ethics choice model. So this saves a formula that is fit to our data set using ordinary least squares by default, if you care about that sort of thing. And then we can look at a summary of our fit model. And see lots of information. So these can be a little bit tricksy to interpret, the output of a logistic regression. So we can pretty much ignore, actually, let me go top to bottom. This is the input formula. So here is our output. Here's the thing we are predicting, whether or not someone will say yes when you ask them if they do something unethical. And then here's all of the possible inputs. But all of these have a multiple levels, right? Gender, in this case, I think we only have male and female. Sexuality has, several levels. Undergraduate major has several levels. And then age has several levels, because in this case you can see it's a scale. It's not sort of like a what am I looking for here? It's not a number, right? Like age is a number, but because this has been binned for anonymity, we don't know, the number for each person. So when we go through here and we look at things, what we can see is each of these rows tells us if you hold everything else constant and just change this from whatever the default is, and the default is picked automatically. So in this case, the default is male. If you hold everything else constant and you just change the gender of male to gender of female, this is the predicted change in your outcome. So in this case, gender female is associated, gender female is associated with a lower number of, a lower probability of someone replying yes when you ask them if they do something unethical. A very small error means we're pretty sure. A very high error means we're not very sure. There's a lot of variance. And then this is a t-test to see if this is, a real distinction. And then this is the p-value. So if there weren't a difference, how likely would we be to get the result that we did get? So that's sort of the way to interpret this, and you can ignore intercept. So going down here, what we can see is that gender seems to be pretty important. It has a relatively large effect, and we're pretty sure about it. We're not uncertain. We can see that gay versus straight doesn't have a strong distinction, but bi queer versus straight looks like it does. And asexual looks like it does as well. It looks like both of these raise the probability. And if we look at majors, so these are all the different level of majors, we can see that it looks like the only ones that reach statistical significance at the 0.01 level are information technology and web development. And if we look at this, we can see that that's these two. So these have a higher probability than these, and none of these have a probability that's low enough to seem robust. So it looks like there isn't a reliable effect of, say, majoring in the social sciences. And you can tell this because, so here's our effect, so it's negative, so it reduces the probability that someone's going to say yes. But the error, sort of like how sure we are, is pretty high, and it's actually higher than the effect. So we're not sure that the error isn't actually zero, right? That the actual effect isn't actually zero, if that makes sense. And computer science is sort of marginally significant. I wouldn't actually trust this result, and I wouldn't trust these as well, because we are looking at a lot of different things. We're making a lot of comparisons. And these numbers are not these p-values are not especially low, especially given the number of individuals that we have in the data set. The other thing that seems to be have a very strong effect is age. And this I'm having a little bit of a difficult time interpreting. So all of them so all of these have a lower value. So this is not against each other, remember. This is against whatever is being used as the default. Then the default, which is below 18, I guess? Let's look at our thingadoodle and see if that makes sense. Yeah, no, that definitely makes sense given, let me zoom out a little bit, this. So Dig said, the original report just reported the percentage of yes, no. One question I had was that if age is a factor, maybe instead of reporting the percentages of raw data, when we generate the data for each major by random sampling from the answers. For example, 30 samples per age category, then we overcome the age composition. Yeah, so you're saying balancing within the age. So we can actually do that using a model like this. So let's actually do that. Ethics. So instead of using sort of reduced sampling, which basically is throwing out data, we can control for age. So we can say we expect age to have an effect, but we want to ignore that effect. And I'm definitely gonna need to actually let me add a couple of cells underneath here so you're not all staring at the very bottom of my screen. Okay, much better. And then zoom in. And I'm definitely gonna need the LME4 package for this. So we're going to use what's called a mixed effects model. And that allows us to hold those things constant. So let's look at just gender. No, let's look at just undergraduate major. And let's hold age constant. And that's, what have I done? I've done an error. I'm getting yelled at. It's definitely LMER that's mixed effects regression, right? We'll check that. Mixed effects. It is definitely possible that I may be typing the words wrong. Show me the example code. Okay. LMER. No, it's definitely, that is the function. So another thing we can do, we don't actually have to tell it to look at the column. We can just give it the column names and then tell it that the data is, tell it what the data is called. And what I'm going to do, just for good coding practice, is I'm going to move this package all the way up to the top. So you load in all of your packages at once. Okay. And it's thinking. Max fun less than 10 times the length of par squared is not recommended. Let's find out what this warning means. Oh, this is going to take a while to fit, by the way. It's a pretty big data set. Let me see why I'm getting this warning. Because I have a lot of parameters. I don't have that many parameters, do I? So I've got undergraduate major, which has, well, okay, no, it does have a fair number of parameters. So what we're doing is we're building a separate model for, basically we're building a separate model for, no, come back. If I double click here, will it get bigger? There we go. So we're basically building a separate model within each level, but we don't have that many levels. Like, I have done this with way more levels. Maybe I have the syntax wrong here. Maybe it's not 1 by h. I could have sworn that was the syntax. So that's the fixed effect. LMER package R mixed effect fixed effect. Aw, Bodo's tutorial. We talked about writing a paper together at some point, and it just did not happen. Oh, does it need to be in quotes? Not in quotes. Does it need to be in? Maybe that's my problem. Maybe it needs to be in. So let's stop you. Let's stop this from running. And let's try putting this in parentheses and see if that helps. Well, I didn't get my little, yeah, okay, that was absolutely the problem. I just left my parentheses out. And then we can do a summary of ethics controlling for age. All right, so when we control for age, there's nothing, there's no effect. And there's a pretty high correlation between some of these effects as well. So especially it looks like a correlation between undergraduate major in CS and a undergraduate major in IT or information technology. Let's see, I'm trying to remember, I think it's called, there's a really nice package for visualizing the output of this type of model. And I think it's called SJP LMER. Let's see. Yeah. But I just want the nice, well, this is German. I just want the nice visualizations. Here we go, for documentation and vignettes. That's what I'm looking for. Love me some vignettes. So a vignette is just a short little R sample. Okay. We may not be able to have any vignettes. There might not be none. Oh, here we go. Linear mixed regression model summary. Plotting. Actually, I think plotting interaction effects might be the most interesting thing to do here. Man, this had a complete spiff up since the last time I used this package. Oh, plot underscore model. So let's try that. Rachel, you seem a little scattered today. I'm very jet lagged. Well, not very. I'm coming back to my time zone. Let's try plot underscore model. There we go. So now you can see. There we go. So now we can see the magnitude of the effects when controlling for age. So the sort of general idea is that, so this is the error. So up here in this model, we had this sort of like standard error. Actually, we can probably plot this model as well. I think that would be illuminating for people. I think it's plot underscore model, and then this one was ethics choice model. So this is looking at the direction and magnitude of the effect for each of the levels that we were looking at. So you can see the only one that looks like it might have a negative effect, so make you less likely to say yes, is social science. But you can also see the estimate crosses 0, so here is 0. And the only ones where the estimate doesn't cross 0 is computer science, information technology, and web development. And if we look at this, we can see sort of like the same thing, but within each level. So we can see that it seems like not being under 18 does have an effect, and it seems to be negative. And this is pretty robust. And it looks like nothing. So compared to this, you can tell that nothing in the majors actually has a very strong effect. And interesting, when we control for sexuality and gender and age, we can see more negative effects in undergraduate major. So that suggests to me that undergraduate major is capturing some of these, what would you call these? Some of these demographic effects, which I don't think is a surprise. Like gender balances across majors are different for a lot of reasons. And we can see that, pardon me. We can see that gender, female is associated with a lower probability of saying yes to this question. And looking at sexualities, they all are associated with a lower probability, with a higher probability of saying yes to this question. But again, like gay crosses 0, and yeah. So that's sort of the story there. And I'm interesting, so this is just this is a mixed effect model. This is just plain old regression model with multiple factors. So I'm interested to see plotting a mixed effect model in particular. Excuse me. Let's see. Was that an option? Yeah, and so we can also have a summary of mixed effect regression models. Oh, that's so pretty. So it's sjt.lmer. And so this is looking at the difference between two models. And one thing you might do, and one thing you might do is you might train a model with and without a specific thing. So, I'm sorry. The reason I'm pausing there is I know I'm going to get yelled at. So you can sort of add a factor, train a model, and then train a second model that is the same model plus a factor, and see if it improves the model, if there's a significant difference between the two models with the factor and without the factor, and if there's an improvement. And that is how I was trained to sort of determine what factors had an effect, but it's definitely not something that statisticians tend to encourage, because you end up doing a lot of comparisons, and it can make something that's not an effect look like an effect, just because you're doing sort of so many tiny adjustments and looking at things so many times. So this is looking at, so this is a model without Kara's level of education. And the same about with that Kara's level of education. Yeah. So I think this is probably, for me, no, not that one. Oh, where'd my very nice, oh, here we go. This one that got unplotted for some reason. For me, I think this is the most interesting chart, and I think it's worth doing for the other ethics questions as well. Oh, goodness, excuse me. Okay, so that is the first one. So this is just a binary. Would you do this thing that is unethical or not? Actually, I think it's worth, so that's the binary, and I think there's also just ethics choice, which has multiple levels. Oh, right, because it, so it will, sorry, it's logistic, so it wants 2 levels. So I think there was another ethics question that I wrote up here that we could take a look at. Ethics report. Oh, and let me put these in at the top again, following best practices. Let's look at the level of ethics report. I think it's worthwhile to like combine the 2 yeses here, because we're sort of looking at, you know, would you report this yes, no, and turn it into a binary? So let's do that. And since I'm working with code and text, I'm gonna zoom in so you can see a little bit better. Get rid of that. So what I'm gonna do is I'm gonna do ethics report by, I'm gonna take data, I'm gonna select ethics report column out of that data frame. And then I'm going to, oh, actually, you know what? I don't need to. I can just mutate it. And I can do string detect. So I'm going to create a new column. Oh my gosh, that's barky dog. So I'm going to take the data frame in. I'm going to create a new column called ethics report by that detects if the string yes. Oh, actually, this is a tidyverse, so it's going to need the column name first. Ethics report. I didn't get any errors. So let's do table data ethics report by. So we should see if we compare this. So this should be the sum. So true here should be the sum of these 2. And that looks right to me. And then false should be the sum of these 2, and that also looks right to me. Excellent. So now we have this binary we can look at reporting. So this is sort of interesting to me, the difference between like, would you do the unethical thing and would you tell other people about the unethical thing? And it looks like more people are willing to be like bystanders than are to actually do the unethical thing, which is interesting. All right, Let's take a look. Oh, excuse me. Let's take a look. So, so most of these effects aren't reliable. So you can see these all overlap with 0, and most of these like touch 0 or really close to it. And a lot of these were also pretty close to 0. And it looks like none undergraduate major and health sciences major are the lowest. So that's sort of interesting. And then web dev is the only thing that's positive. Interesting. So let's also look at, so this was the, I'm going to add myself a little comment here. Counted together. Okay. So here we're counting all the creating this column where we count the yes answers, and then here we are seeing if there's an effect of any of these demographic qualities on it. And looks like not really. Definitely not as strong as there was for these. So you can see that the error bars on these are smaller. So basically, the smaller the error bars and the farther away from 0, the more sure we are that there's an effect. And looks like maybe age has an effect here, in that people who are under 18 are more likely to say that they will do the unethical thing. But if we look at whether or not they'd report, it looks like age isn't really a factor. Gender isn't really a factor. Sexuality isn't really a factor. Maybe some majors are, but it's not really robust. Yes, positive means that they reported either within the company or without the company. Within the company or outside of the company. Yeah, to answer Mehdig's question. I'm not sure how your name's supposed to be pronounced. It's just like, I'll take some swings at it. And then the third question we were looking at was, who do you believe is ultimately most responsible for code that accomplishes something unethical? And I don't... Mehdi. Okay. I don't know that it makes sense to break this down. So these are the effects. I'm just trying to decide. Yeah, I think that ethics responsibility is less interesting to me. I think I'm mostly interested in the ethics choice and the ethics report. And I think the thing that's going to be most interesting for me, so it is sort of interesting to see these outputs of the model, but it's not the most like good to look at. Output, I think it would be nicer to have a better look at effects of demo. I think it would be better to have a more sort of like scannable actually, let's control for a lot of things. To have a more scannable thing that we can just sort of look at, and gender. More scannable thing where we can just sort of look at and have like one plot and be like, look, here's the thing. Yeah, it looks like that adding these additional features to control for didn't really have a strong effect. So I think the thing that I'm interested in is this gap between willingness to do the unethical thing and willingness to report the unethical thing, because it looks like more people said that they wouldn't do the thing but then would report it. Yeah, that's a good question. So what we did is we looked for things that were yes. So yes is 1 and everything else is 0. So higher is more likely to report and lower is less likely to report. Does that seem right? Let's look at age to see if that's the case. Oh, interesting. Okay, so it looks like we might have some missing data. Actually, let's do, instead of, I'm just trying to decide if I want to change the level so it's a little bit easier to read, and I think I don't want to. I don't think I care that much. I want to see if there's a relationship between the willingness to do the unethical thing and tell other people about it. And I think that'll help clear up sort of the whether it's the opposite or not, because I'm confusing myself at this point. Also, I need to move these at a time other than literally the last thing I do in the week, because I'm always just super exhausted at this point. All right, data. And the things that I'm interested in are ethics. Report by and ethics. Choice by and I guess density makes sense? I don't think density makes sense. Yeah, it's not gonna work. And I don't think point's gonna work either. Pointin. That's definitely not gonna work. Oh, it'll plot me points. Okay, so NA are people who left it blank. So I think density 2D would be helpful here. Can I do a bar plot? Will that work? It will not. Can I do this? No. Friends, I'm a professional data scientist and I cannot make a bar plot. ggplot, bar plot, multiple variables. That is exactly what I want. So let's actually... Okay, this works. Excellent. So true is the people who do report it. So we can see that most people wouldn't say anything, or would say it depends. And then some people just don't have an answer and they left it blank. So I'm interested in the relationship between what you say on this question and what you say on the other question. Multivariate bar plot R. Mosaic plot. Yes, that is what I want. I want the mosaic plot. Yeah. Okay, excellent. I'm just gonna copy and paste all of this. Whoop. data. And then the fill should be ethics choice by Jupyter. Well, okay, that didn't work. Okay, also that didn't work. What if I do color? Okay, okay, that kind of worked. Okay, so most people who don't answer one question don't answer both questions. I think I actually don't need color. Yeah, there we go. So I think the first thing I'm gonna do is drop the NAs. And then from there, this person has done their indenting weirdly. From there, I'm gonna plot it. So it should get rid of all of these NAs we don't need. And it got rid of everything. Beautiful. That's not what I wanted. Does that work? That does not work. Does that work? Okay, so the things that have, it looks like a lot of rows have at least one NA, which is the problem. I should be able to get, yeah, that's what I want. That's what I want. Okay, awesome. Except now I want fill. Beautiful. So here we see whether or not someone would make the ethical choice, and then on this axis we see whether or not they would report it. And what we can see is that most people would not write the unethical code, but of those, about half of them wouldn't report it or says it depends on whether, or says it depends. Interesting. And then I'm going to facet wrap this by, get rid of this, I don't need that anymore, major. So we can look at each major separately. And I think that would be probably a good place to stop. Let's see what that looks like. Interesting. I think there's a way where you can say, show me so the scales of these are obviously very different, and you can see that there's a lot of computer science majors in the Stack Overflow Developer survey, which, I mean, fancy that. That's sort of interesting, huh? It looks like there's none and NA. So I'm wondering if I can change these scales so that they are all free, and I think I can. Yeah, there we go. So we can compare them sort of on their own merits. Nope, we can't. I thought that's what that was gonna do. It did not. There we go. Interesting. So what we're looking at now is no pattern. It looks like it's pretty much pretty much the same throughout. That most people wouldn't do the unethical thing, so that's the difference in size of these bars. But most of them also wouldn't report that an unethical thing had been done. And wouldn't tell other people about the unethical thing happening. So, yeah. So it looks like, well, it's interesting. Major is not a super robust effect. But there is, at least for whether or not someone would do the unethical thing, a fairly robust effect of age. So older people are less likely to do the unethical thing than people under 18. And there's also a kind of fairly robust effect of gender. I don't know. I don't want to read too much into this. But yeah, so that's what we discovered in this sort of quick little exploratory thing. And I'm actually gonna get rid of all of the plots from the original so we can just look at sort of the new stuff. And I will commit and run this and make it public, even though it's like a little bit it's not the most polished code I've ever written, but all right. Thanks for joining me today. Hopefully we all learned something interesting. I certainly did. I think this is a really cool, interesting data set. And I will be back on Friday, and I will next Friday, this time I promise, we're going to get back to the deep learning. And I am looking forward to that project, but this sort of like came up and I was like, oh, this would be a good thing to answer in my stream. All right. I'll see you guys next Friday. Bye-bye. Well, thanks for joining.